If limit extends to a of f of x is equal to f of c, that is, if the limit exists and the value of limit is equal to the functional value, then the function is said to be continuous at c. Limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a. That means left hand limit is equal to right hand limit is equal to functional value, then the function is said to be a continuous function. Whenever substitutions are taken, the value of limit also changes. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to take the revision of the very important chapter, that is very important chapter in calculus, that is continuity and differentiability. This is very important chapter. So, before going to exact chapter, let us know what are the types of questions and what is the weightage of this chapter. So, in this chapter, you are going to get one mark question, one mark questions, and 2 marks 3 questions. So, you will get 3 questions from 2 marks, then 3 questions again from 3 marks. For 3 marks 3 questions, 2 marks also 3 questions, and one 4 marks question, that is in part E, and one 5 marks question in part D. So, in all parts we will have a question. So, 1 mark 1 question and 2 marks 3 questions, 3 marks 3 questions, then one 4 marks question and one 5 marks questions. Totally 5 plus 4 9, 9 plus 9 18, 18 plus 1 19 plus 6 is 25 marks. So, the weightage for this chapter is 25 marks. So, 4 mark question is for part E. In part E, you will get one 4 marks question along with a linear programming problem for 6 marks and one question from 4 marks from continuity. Properties of integrals for 6 marks and then one question from this part E, that is for 4 marks. And whereas in part D, for 5 marks question, you will get one question from this and another one more question from application of differentiation. So, right. So, you will get a question from the second derivative. So, in part D, for 5 marks, you will get a question from second derivatives, whereas for part E, you will get one question for 4 marks from continuity, and the remaining and 2 marks, 3 marks and 2 marks questions, 3 marks question and 1 mark questions are from different types of differentiations. Now, before going to the differentiability, let us know regarding the continuity. Let us discuss regarding the 4 marks question. Right. Usually, you will get one 4 marks question from continuity. Now, suppose what is the definition of a continuous function? Suppose f is a real function and let c be a point in the domain of the function, which is f is continuous if the limit exists and is equal to functional value. If limit extends to a of f of x is equal to f of c, that is, if the limit exists and the value of limit is equal to the functional value, then the function is said to be continuous at c. That is, suppose f is a real function and let c be a point in the domain of f, then f is said to be continuous at c if limit extends to a of f of x is equal to f of c. In general, if the left hand limit LHL and the right hand limit RHL and the value of the function at x is equal to c exists, if the left hand limit and the right hand limit and the value of the function at x is equal to c exists and they are equal and all equal to each other, then the function f is said to be continuous at x is equal to c. If the left hand limit is equal to right hand limit is equal to functional value, then the function is said to be continuous at x is equal to c. That is, right hand limit and left hand limit is equal to functional value. That means, the left hand limit and right hand limit coincide at x is equal to c, that is denoted as LHL is equal to RHL is equal to f of c, then the function is said to be a continuous function. How to represent? That is, left hand limit is equal to right hand limit means you might have been studied. Limit extends to a minus f of x is called the left hand limit is equal to right hand limit. Limit extends to a of a plus f of x is called the right hand limit, and this is equal to functional value. So, limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a. Left hand limit is equal to right hand limit is equal to functional value. then the function f of x is said to be continuous at x is equal to a. If it is not equal, then the function is said to be discontinuous, not continuous, right? Now, let us take a simple example. Now, let us come to an example. Show that the function f of x equal to x cube plus 3 if x is not equal to 0, 1 if x is equal to 0 is not continuous at x is equal to 0. Now, here it is given. What is given? If x is not equal to 0, x is not equal to 0 means x is less than 0 or x is greater than 0. So, therefore, limit x tends to 0 of f of x is equal to limit x tends to 0 of, what is f of x here? X cube plus 3. Now, just put x is equal to 0, 0 cube plus 3 is equal to 3. So, here the value of limit is equal to 3. When x is equal to 0, that is given already. When x is equal to 0, f of x is equal to 1. That means f of 0 is equal to 1. What do you say here? Limit x tends to 0 of f of x is not equal to functional value. F of x, the limit value is 3 and the functional value is 1. They are not equal. So, therefore, the function f of x is said to be discontinuous. F of x is not continuous. Therefore, f of x is not continuous at x is equal to 0. That means it is discontinuous function. Hope you followed. Now, move on to the next problem. A similar type problem. If f of x is equal to x plus 2, if x is less than or equal to 1, x minus 2 if x is greater than 1, check the continuity of the function, whether it is continuous or not. Now, at x is less than 1. So, when x is less than 1, f of x is equal to x plus 2. Again, when x is greater than 1, the functional value is equal to x minus 2. Now, let us write down the left hand limit. First, left hand limit. Left hand limit is equal to limit x tends to 1 minus f of x. That is limit x tends to 1 minus, when x is less than 1. What is less than 1? F of x is less than 1 means, if x is less than 1 means f of x is equal to x plus 2. Put x is equal to 1. 1 plus 2 is equal to 3. This is left hand limit. On the other hand, find out the right hand limit. RHL is equal to limit x tends to 1 plus f of x. So, here limit x tends to 1 plus f of x. When x is greater than 1, f of x is x minus 2. That is 1 minus 2 is equal to 1 minus 1. So, left hand limit is equal to 3 and right hand limit is equal to minus 1, and the functional value at x is equal to 1. What is f of x? We have f of x is equal to x plus 2. So, put x is equal to 1. So, f of 1 is equal to 1 plus 2 is equal to 3. Now, what do you say from this? Left hand limit is equal to right hand limit is equal to functional value. That is functional value f of 1. What is left hand limit? We have left hand limit as 3 and the right hand limit as minus 1 and the functional value is equal to 3. They are not equal. That means left hand limit is not equal to right hand limit is not equal to functional value. Therefore, f of x is not continuous. F of x is not continuous at x is equal to 1. This is discontinuous function. That's it. This is how we are going to verify the continuity for the given function. Now, move on to the next problem. Now, a function f of x is, so you got an idea regarding continuous function. That means a function f of x is said to be continuous function at x is equal to a if limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. That means left hand limit is equal to right hand limit is equal to functional value. Then the function is said to be a continuous function. Otherwise, it is a discontinuous function. Now, move on to 4 marks, very important type problems for the point of examination. Let us take this type of problems. These are a very important problem for 4 marks. Find the value of k. So, you may expect one question from this for 4 marks in part E. Find the value of k so that the function f is continuous at x is equal to 5. So, what is given here? Here the value of a is equal to 5. Now, when x is less than 5, when x is less than 5, the functional value f of x is equal to kx plus 1, right. Then you will get less than means you will get left hand limit. Left hand limit is limit x tends to a minus f of x is equal to limit x tends to 5 minus f of x is equal to kx plus 1. So, this is equal to, put x is equal to 5, then you will get 5k plus 1. This is left hand limit. On the other hand, when x is greater than 5, what is given? F of x is equal to 3x minus 5. So, you will get the right hand limit. Right hand limit is equal to limit x tends to 5 plus f of x, that is limit x tends to 5 plus f of x. What is f of x? 3x minus 5. Now, put x is equal to 5. So, 3 into 5 minus 5, that is 15 minus 5 is equal to 10. Right. Next, and when x is equal to 5, the functional value f of x is equal to, what is f of x? Kx plus 1. Now, what is f of 5? If you put x is equal to 5, f of 5 is equal to k into 5 plus 1, that is 5k plus 1. Now, what is given? Since f of x is continuous, therefore left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? Left hand limit is equal to 5k plus 1. Right hand limit is equal to 10 and the functional value is also equal to 5k plus 1. Since f of x is continuous, at x is equal to 5, therefore left hand limit is equal to right hand limit is equal to functional value. Let us equate any first and second. 5k plus 1 is equal to 10, 5k is equal to 10 minus 1 is 9, therefore k is equal to 9 by 5. That's it. So, the value of k is equal to 9 by 5. This is how we are going to find the value of k. So, if you do this much, definitely you will get a 4 marks. Very important type problem. Now, let us move on to the next problem, similar type problem. Let me take another problem. So, here what is given? Find the value of k if f of x is continuous at x is equal to pi. Similar type problem, instead of 5 we have pi here. Now, since f of x is continuous at x is equal to pi, therefore limit x tends to pi minus f of x is equal to limit x tends to pi plus f of x is equal to functional value. Left hand limit is equal to right hand limit is equal to functional value. Straight away you can write. So, what is f of x? At x, f of s at x is equal to pi, f of x is equal to, at x is equal to pi, f of x is equal to kx plus 1. F of pi can be written as k into pi plus 1. Now, limit x tends to pi minus f of x, left hand limit less than means you will get kx plus 1 is equal to limit x tends to pi plus f of x. If x is greater than pi, f of x is cos x, and functional value at x is equal to pi, f of pi is equal to k pi plus 1. So, just substitute the value of limit, put x is equal to pi, then this becomes k pi plus 1 is equal to cos pi is equal to k pi plus 1. Now, simplify, that's it. Now, this can be written as here k into pi plus 1 is equal to cos pi, cos 180. Cos 180 is equal to minus 1, that is also equal to k pi plus 1. Equate first and second. K pi plus 1 is equal to minus 1, k pi is equal to minus 1, that's equal to minus 2. Therefore, k is equal to minus 2 divided by pi. That's it. So, the value of k is equal to minus 2 by pi. So, if you do this much, definitely you will get 4 marks. Hope you followed. Very important problem indeed. Just straight away write LHL, RHL and functional value, simplify, you will get the answer. Now, move on to the next problem, same type problem. Find the value of k if f of x is equal to kx square, where x is less than or equal to 2, 3 if x is greater than 2 is continuous at x is equal to 2. This is also given. What is given? Since f of x is continuous at x is equal to 2, therefore left hand limit is equal to right hand limit is equal to functional value. So what is left hand limit? Limit x tends to 2 minus, when x is less than 2 we have kx square is equal to limit x tends to 2 plus, when x is greater than 2 f of x is 3. Now what is the functional value? So f of x is equal to kx square at x is equal to 2. So this is, if you write f of 2, then you will get k into 2 square, that's equal to 4k. This is equal to 4k. Just substitute the value. So here put x is equal to 2, 2 square, 4k is equal to 3 is equal to 4k. 4k is equal to 3, therefore k is equal to 3 divided by 4. That's it. This is how we are going to solve. This is also a very simple problem. Now, hope you followed. Now move on to the next problem. Now, this is an important type problem. Find the value of k if f of x is equal to k into cos x divided by pi minus 2x if x is not equal to pi by 2, and 3 if x is equal to pi by 2 is continuous at x is equal to pi by 2. Since when x is not equal to pi by 2, when x is not equal to pi by 2 means x is less than pi by 2 or greater than pi by 2, therefore limit x tends to pi by 2 is the left hand limit as well as the right hand limit. Limit x tends to pi by 2 of f of x is equal to, this is k into cos x divided by pi minus 2x. Now, simplify this first. So, here this can also be written as limit x tends to pi by 2 of k as it is cos x, since cos theta is also equal to sin 90 minus theta. What is sin 90 minus theta? Cos theta. So, this cos x can also be written as sin of pi by 2 minus x. What is sin 90 minus theta? Cos theta. Here divide by 2, then this becomes 2 out, pi by 2 minus x. See? So, if you multiply 2 and 2 gets cancelled, pi minus 2x. Now, let us evaluate this by taking the substitution. Put pi by 2 minus x is equal to theta. Now, whenever substitutions are taken, the value of limit also changes. What is the limit here? When x is equal to pi by 2, when x is equal to pi by 2, theta is equal to pi by 2 minus pi by 2, that's equal to 0. So, theta tends to 0. This becomes limit x tends to pi by 2 becomes theta tends to 0 of this k as it is sin of pi by 2 minus x is theta, sin theta divided by pi by 2 minus theta is theta, pi by 2 minus x is theta. Now, you can take this along with the 2, k by 2 is the common factor, and what is sin theta by theta? 1, that's equal to k by 2. So, the value of limit is equal to k by 2. Okay. Now, this is the final important step. See here, when x is not equal to pi by 2 means limit x tends to pi by 2 of f of x is equal to limit x tends to pi by 2 of k cos x divided by pi minus 2x. So, just cos x can also be written as sin 90 minus x, because sin 90 minus theta is cos theta, and now here this can be written as k into sin 90 minus x divided by 2, you can take 2 common factor, then this can be as k by 2 minus x. Put pi by 2 minus x is equal to theta. Whenever substitutions are taken, the value of limit changes. When x tends to pi by 2 implies theta tends to 0, then this becomes theta tends to 0, k into sin theta divided by 2 into theta, k by 2 constant, sin theta by theta is equal to 1, that's equal to k by 2. Now, since what is given, find the value of k where f of x is continuous. Since f of x is continuous at x is equal to pi by 2, therefore limit x tends to pi by 2 of this k into cos x divided by pi minus 2x is equal to the functional value is equal to 3. Now, what is this value we got from this? So, k cos x divided by pi minus 2x is equal to k by 2. This is equal to k by 2 is equal to 3. Therefore, k is equal to 3 into 2 is 6. K is equal to 6. That's it. This is how we are going to solve this problem. Hope you followed, right? Now, move on to the next problem. Let us take one more example. Find the relation between a and b so that the function defined by f of x is equal to x plus 1 if x is less than or equal to 3 and bx plus 3 if x is greater than 3 is continuous at x is equal to 3. Now, what is to find here? Find the relation between a and b so that they are continuous at x is equal to 3. Now, since f of x is continuous at x is equal to 3, therefore, left hand limit is equal to right hand limit is equal to functional value. So, here this is limit extends to 3 minus left hand limit ax plus 1 is equal to limit extends to 3 plus right hand limit bx plus 3 is equal to the functional value. When x is equal to 3, f of x is equal to at x is equal to 3, f of x is equal to ax plus 1. So, f of 3 is equal to 3a plus 1. Substitute here 3a plus 1. Now, put the value, just substitute the value of limit. So, this is 3 into a plus 1 is equal to 3 into b plus 3 is equal to 3a plus 1. Let us equate first and second. 3a plus 1 is equal to 3b plus 3. Now, what is to find the relation between a and b? That's all. So, take 3a is equal to 3b plus 3 plus 1 becomes minus 1, 3b plus 2. Now, divide by 3. If you divide by 3, you will get a is equal to 3 gets cancelled, b plus 2 by, this is the relation. So, a is equal to b plus 2 by 3 is the relation between a and b. That's it. So, if you do this much, you will also get 4 marks. Sometimes they may ask to find the value of a and b. That is also important for the point of examination. These are few problems based on a continuity, first part. So, you will expect one 4 marks question from this type. Now, move on to the second part of the chapter, that is derivative of the function. So, differentiability. Now, you might have been studied regarding the standard derivatives. In the first PUC itself, you have studied regarding the standard derivatives. Let me recall the very important formula is d by dx of x raised to n is nx to the power of n minus 1. Differentiation of x raised to n is nx to the power of n minus 1. For example, now you know derivative of a constant is 0. Derivative of a constant d by dx of constant, that is d by dx of 2 is equal to a constant 0, or d by dx of a. If a is a constant, then it is 0. d by dx of x, derivative of x is 1, differentiation of x square is 2x, differentiation of x cube is 3x square, because what is n here? N is equal to 3x to the power of 3 minus 1, that is 3x to the power of 2. Derivative of x cube is 3x square. Similarly, derivative of root x is 1 over 2 root x, d by dx of 1 by x is minus 1 by x square, and derivative of e to the power of x is e raised to x itself, right. Now, d by dx of log x, derivative of log x to base is 1 over x, d by dx of trigonometrical function sin x is cos x, differentiation of cos x is minus sin x, d by dx of tan x is secant square x, d by dx of cot x is minus cosecant square x, d by dx of secant x is secant x into tan x, d by dx of cosecant x is minus cosecant x into cot x. Very important. So, differentiation of log x is 1 over x, sin x is cos x is minus sin x, tan x is secant square x is, cot x is minus cosecant square x, and secant x is secant x into tan x, and cosecant x is minus cosecant x into cot x. Now, you might have been studied regarding the rules of differentiations. Now, here let us take for example in rules of differentiation. Now, suppose if you differentiate d by dx of x cube plus 4x square plus e raised to x plus 3 log x. Now, this can be differentiated term by term differentiation, that is d by dx of x cube plus 4 constant d by dx of x square plus d by dx of e to the power of x plus 3 constant d by dx of log x. This is term by term differentiation. Now, differentiation of x cube is 3x square plus 4 into differentiation of x square is 2x plus derivative of e to the power of x is e power x and derivative of log x is 1 over x. So, if you want, you can multiply 3x square plus 8x plus e power x plus 1 over x is the differentiated answer. Now, You might have been studied regarding the product rule and the quotient rule. D by dx of uv is equal to u into dv by dx plus v into du by dx, that is the product rule. And derivative of u by v, quotient rule, numerator by denominator, denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. Now, they are all, these are all you might have been studied in your previous, that is in first PUC itself. Now, here in second PUC, it starts from function of a function, that is composite function. Differentiation of a composite function. Composite function means function of a function is called the composite function. To differentiate such a function, what is the formula we are going to use? We can differentiate using a rule that is called chain rule. Differentiation of a function, composite function is nothing but a chain rule. So, that is if d by dx of f of x to the power of n, function to the power of n, just ordinary differentiation, n into f of x to the power of n minus 1 into d by dx of that inside function. N into f of x to the power of n minus 1 into d by dx of that inside function will give the chain rule. Now, let us take an example. For example, if y is equal to 2x cube plus 1. So, differentiate this. Let us take y is equal to 2x plus 1 whole cube. Now, differentiating with respect to x, dy by dx is equal to f, this is f of x to the power of n. What is n? N is 3 into 2x plus 1 whole to the power of 3 minus 1 into d by dx of inside function. Inside function is 2x plus 1. F of x to the power of n. N is 3, f of x is 2x plus 1 to the power of 3 minus 1 into d by dx of inside. This is 3, 2x plus 1 whole square. 2 into differentiation of x is 1 plus 1 constant 0. This can run as 2 3s are 6. 6 times 2x plus 1 whole square. That's it. One more question. On the other hand, take this. Y is, yes, what is this? Tan of 2x plus 3. If you differentiate this, let us consider, let y is equal to tan of 2x plus 3. Differentiating with respect to x, dy by dx is equal to d by dx of tan of 2x plus 3. Let us consider this as x. What is differentiation of tan x? Secant square x. Secant square, instead of x we have 2x plus 3 into d by dx of this inside function 2x plus 3. So, secant square 2x plus 3 into differentiation of 2x is 2 plus 3 constant 0. 2 secant square 2x plus 3 is the derivative for this function. This is how we are going to differentiate a function of a function, composite function, that is by chain rule. Move on to the next problem. Differentiate the following with respect to x. So, these are all 1 marker question. So, I may expect for 1 mark. So, what is given here? Y is equal to sine of x square plus 5. Differentiating with respect to x. If you differentiate, you will get dy by dx is equal to d by dx of sine of x square plus 5. Let us call it as x. What is differentiation of sine x? Cos x. X is nothing but x square plus 5 into d by dx of this inside function x square plus 5. So, this is cos of x square plus 5 into differentiation of x square is 2x. That's it. So, differentiation of sine is cos x square plus 5 into d by dx of x square plus 5. X square is 2x plus 5 constant 0. So, 2x cos x square plus 5. On the other hand, let us take this. Y is equal to cos of sine x. Differentiating with respect to x, then dy by dx is equal to d by dx of cos of sine x. Now, let us call it as x. What is differentiation of cos x? Minus sine of sine x into differentiation of sine x is cos x. That's it. So, here cos x, differentiation of cos x is minus sine x. Instead of x, we have sine x into d by dx of sine x is cos x. 1 marker. Move on to the next type problem. So, differentiate the following with respect to x. Sine of cos x square. Now, this is also same. Let us consider y is equal to sine of cos x square. Now, let us call it as x. Dy by dx is equal to d by dx of sine of cos of x square. Now, this is x. Differentiation of sine is cos x, cos of cos x square into d by dx of here inside function is cos of x square. This is function of a function of a function. Now, this is equal to cos of cos x square as it is. Now let us consider this as again a function of a function. Cos, differentiation of cos x is minus sin x square into differentiation of x square is 2x. That's all. So here sin x, differentiation of sin x is cos x. X is nothing but cos x square into d by dx of inside function is cos x square. Second differentiation of cos x square is minus sin of x square into differentiation of x square is 2x. So here y is a function of u and u is a function of v and v is a function of x, then dy by dx is equal to dy by du into du by dv into dv by dx. Composite form, that is chain rule. That's it. Now let's take this problem. Differentiate the following with respect to x. So this is nothing but of the form u by v, the quotient rule. Y is equal to sin of ax plus b divided by cos of cx plus d. This is u by v. Denominator dy by dx is equal to differentiated denominator cos of cx plus d into d by dx of numerator, that is sin of ax plus b minus numerator sin of ax plus b into d by dx of denominator. Denominator is cos of cx plus d divided by the denominator square. What is denominator square? We have cos of cx plus d whole the square. Now this can be written as cos of cx plus d into differentiation of sin is cos ax plus b into differentiation of ax plus b. Again a is a constant, x is 1, this is a, minus this is as it is sin ax plus b into differentiation of cos is sin minus sin cx plus d into differentiation of cx is c divided by the denominator square, that is cos of cx plus d whole the square. That's it. This is how we are going to differentiate u by v method. That's it. So these are few problems on derivatives. So you will expect one 4 marks question from continuity and one 1 mark question from derivatives. That's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you very much.